Everyone likes the loudest thing, everyone likes the biggest thing, and this is the loudest and the biggest in one hit. And it's awesome.
So definitely no boring days here at Alauda, that's for sure. Yeah, they're working. Goodwood was a great opportunity for us to showcase like this full-scale prototype to the world.
Welcome Goodwood SpeedWeek to Alauda Aeronautics here in Adelaide, South Australia, where we're going to give you the first sneak peek of our full-size speeders.
In the past month, we've welcomed new members into the Alauda family. So one of those being Aaron M. He's our workshop technician. He's got a great background in the marine industry and also automotive industry. So Mitch has come on board as well, Chief Remote Pilot. Every time he comes into this workshop, his eyes widen with excitement. So I think he's going to be a great addition to the team.
Ready when you are. Army. Good.
It's electric, it's environmentally friendly, it's amazing. Like, look at the thing, it's crazy. We're really eager to show you all the footage. We're just waiting for the approvals to come from CASA so that we can film exactly what we want to film commercially and do this all in accordance with the civil aviation safety regulations. Then that's going to give us a good platform to be able to manoeuvre it in pretty much any fashion that we want. I want to see it fly upside down. I think that's going to be cool. High-speed turns, high-speed racing style scenarios, close proximity to the ground. So anything that looks volatile is what we're trying to achieve. Working with the regulator is really important for safety, but it also gives them a level of oversight and assurance that what we're doing is going to work. We're not developing a backyard helicopter. That's what we need to understand here. Inherently, motorsport is really dangerous. Aviation can have an element of danger as well, and combining the two creates a unique scenario where the safety aspect of the Airspeeder series is critical and important to what we're trying to achieve.
Each collision avoidance system is basically composed of 3 or 4 components: perception, data fusion, and control. The first step is perception, so it's using the sensing from the environment. It can be a map. For example, if we are able to draw a 3D map of the environment, we can have a very accurate model of the world. What we are trying to do is to put a man in the speeder, so there will be commands from the pilot, the input for the control system. We want to merge this data, these inputs, with the input from the collision avoidance system to make this shared control. If we want to race on the water, we will have to test our sensors on the water. We also have to take care of sand as we are running in the desert. We have to adapt to this environment.
Slightest breath of wind, barely anything, just beautiful.
So you should be good now to connect the motor power.
Arming.
That's a flying car. I guess that's it.